So here we want to find the equation in slope-intercept form of the line that's tangent to g of x equals x squared over x plus 7 at x equal to -2. And we want to look at the answer, or have the answer in slope-intercept form. So how do we find the equation of the line tangent to a function? Well, we need a point and we need a slope. Now for the point, they gave us the x-coordinate of our point, -2, but we have to find the y-coordinate of the point. Well, we just put that value of x into the function, so our y-coordinate is just going to be, in this case, g of -2. So what is g of -2? Well, if g of x is x squared over x plus 7, then g of -2 is going to be -2 all squared over -2 plus 7, which is going to be 4 over 5, so 4/5. Now what about the slope? Well, the slope is going to be, for the tangent line, the value of our derivative at that value of x, -2. So we want to find the derivative of g and then evaluate it at -2 to get the slope. So first, let's go ahead and find the derivative. If we know that g of x is x squared over x plus 7, what is g prime of x? Well, g is a quotient of two functions, x squared and x plus 7. So to find the derivative, we're going to need the quotient rule. So we're going to take the derivative of the top, that's going to be 2x, times the bottom function, x plus 7, and then we're going to subtract, because of the quotient rule, the derivative of the bottom, which in this case is just 1, times the top function, which is x squared, and we have all of that over the bottom function, x plus 7 squared. So now what we're going to want to do is evaluate that at -2. So the derivative at -2 is going to be 2 times -2 times -2 plus 7 minus, that's our quotient rule minus sign, and then we have -2 all squared over -2 plus 7 squared. So what is that? Well, let's see, we have -4 here, and then we have 7 minus 2 is 5 here. So we've got -20. This right here is just 4, so we have -20 minus 4. And then here we have 5, 7 minus 2 is 5 squared, or 25. So we have -24 over 25. So the slope is -24 over 25. So now we have a point and a slope. We can use those to find the equation of the line in slope-intercept form. We have y minus the y-coordinate of our point, which is 4/5. And that's going to equal our slope, which is -24 over 25, times x minus our x-coordinate of our point, which is -2. So that's going to be y minus 4/5 equals -24 over 25 times x plus 2. And now, since we want that in y equals, we're going to have to just bring that 4/5 over. So let's add 4/5 to both sides, and that's going to give us y equals -24 over 25 times x plus 2 plus 4/5. Now we distribute that -24 over 25, so we have y equals -24 over 25 times x, and then here, when we multiply by 2, we've got -48 over 25 plus 4/5. But instead of 4/5, since I want to combine it with the -48 over 25, I'm going to write this as 20 over 25. So when I have -48 over 25 and I add 20 over 25, well, that just gives me -28 over 25. So I'm going to have y equals -24 over 25x minus 28 over 25. So which answer would that be? That would be this answer here, -24 over 25 times x minus 28 over 25. Now when we're finding the equation of tangent lines, we can check if we graph the original equation and we graph the equation of the tangent line. So I went ahead and did that using a Desmos. In red, I graphed the original function, x squared over x plus 7. In blue, I graphed the equation of the tangent line, -24 over 25x minus 28 over 25, and then I plotted the point -2 4/5. So if we have the right equation of the tangent line, it's going to go through the point, which it does, and it's going to touch the graph at that point, which it does, and be close to the graph for values near, or points near that point. So close to -2, for values of x close to -2, the line should be close to the graph of x squared over x plus 7, which it is. So that's the way we can get some supporting evidence for our answer, is by graphing the equation and the tangent line.